Intermediary devices, the definition, as opposed to an originator or destination or source of a message, it would be a propagator of the message.
That is when it goes bad or it routes to another message. It's a bunch of
What would your definition of hub mean? Like a gateway device.
In network terminology, is different than a switch.
what is a inversion?
A switch is better file.
Oh, I know that test. Is that on the test? I don't even remember what.
A hub basically, if you plug 4 devices in and they're 100 meg Ethernet, they're all on the same wire.
Right. So
The
that's
hub connects them all. Unintelligent, it doesn't know what port is what, so they share that one connection from the hub to the uplink.
right. So what I said earlier was the device that allows you to connect. So with the hub, you would have a private router.
A hub is a shared connection, basically, like I said, a switch each individual port is 100. Yeah. Whereas for yes, each port that the computer connects to is 100 meg, but it is literally shared wire. Since I'm transmitting, you can't do anything but listen. Whereas with a switch, you can talk and I can talk at the same time. The switch don't care because on the back end, it has fabric intelligence to connect and deliver. So you can talk and listen at the same time.
Okay, I get it.
Multiplex, duplex, it works.
Has to do with
One is multi-capable, the other one is whatever.
Well, no, it's literally the shared connection. It's whether it's a bidirectional or unidirectional.
So this is the prio system.
Doesn't really matter. But the intermediary devices are routers, switches, wireless routers, multiplex switches, firewall devices. Some businesses will have
What was the question?
Is quality of service.
Oh, what is quality of service? Okay. So what was, did you have the answer?
No.
So what answer did you provide?
This is when bandwidth is assigned to a task in a particular order.
Yeah,
Priority system is how I look at it.
it's exactly that. And that's a good way to reterm it, right? It's a priority system, so you can prioritize data traffic, you could prioritize chat traffic, you could prioritize voice
Yeah, so I just
traffic.
remember, like, the video calls, it said
Yeah.
specifically like I would make that like a prio because that needs the most bandwidth.
Yeah.
Versus someone like just serving the internet.
Exactly. Yeah, good question. All right, what do you got?
What does cloud computing allow?
What is what?
What does cloud computing allow?
It allows storage on a virtual network.
That's good.
So that simplifies.
Yeah. What else do you have? Yeah, because there's probably a lot of things. Hybrid. Yeah. And like it allows you to like offload the equipment from your own property, right? There's all kinds of stuff.
The Google Photos, I love that one.
Yeah.
Upload all my photos on Google Drive.
Well, and I mean, so many things are moving to the cloud. Again, like here, you know, I think
Like hard drives no matter what.
they're gone, for sure. For sure.
It's a
Like,
scary thing to think about because I feel like it's more prone to security issues.
I think it is. But like, I have a computer that I built in the AWS cloud. So all I need is a monitor and a keyboard and a mouse. I do have a computer, but I built one in the cloud just so I can do it and see. And so when you you go in, it asks you like, what size RAM do you want? And you like, I would like a 512 SSD. You click on it, and it, yes. And eventually, we'll do away with it at the schools. It'll become less expensive because it would be like a monthly expense instead of a capital expense. It's gonna happen. It's gonna happen. Yeah, learn cloud. You know, especially if you're interested in cyber, cloud security, because that's where it's gonna be. All right. We got a good question? Let's see. How do end devices communicate? Are you asking me or Joey? I'll contribute.
Like, for what thing?
Yeah, like, because that's kind of a vague question because there's a lot of different ways to answer it. Do you mean like the network piece of it or media? Or do you mean like the types of networks, a client server, or?
Malware.
How do they begin communication?
Like my brain's thinking to the point, like,
Do you know when
this is a broadcast port, but that doesn't have much to do with this.
So do you mean like they join a network, they get an IP, they join a network, they get an IP address?
Right now, this end device is in the network,
Yeah.
and it wants to communicate. You don't get that. How does it communicate?
It needs the address.
So it sends out a request for a dynamic address, and once it has an IP address, it can start to communicate with other devices. Or if it's on the LAN, it doesn't even really need an IP address. It can communicate through the MAC addresses. It's a lot, I mean, there's a lot of different ways. So what do you have as an answer? Let's see what you were going for.
End devices begin communication by using the address of the destination end device to deliver a message.
Oh, yeah. Okay, I get that. So read the question to me again.
End devices begin communication by using the address of the destination end device.
And what was the original question?
Like I said, how end devices communicate.
Okay.
So basically,
Availability.
Yeah. So I think one way to think of it too is like there takes three things in order for there to be communication. You have to have a source device, right? And then you have to have the media or the channel that it goes across, and then the destination. So that would be another way of saying what you said, you know, so the source device knows what the destination is, and then it begins to initiate a conversation. Yeah. That's good.
It's like a peer-to-peer, you don't really need much addressing because it's just
Exactly.
only those two things on the network.
Exactly. As long as they have a MAC address, they can communicate. Yeah. And a channel. Yeah.
Kind of concerned if it didn't have a MAC address because everything does.
Everything does. Yeah. Exactly. Everything does. Yeah, so for there to be any communication between devices, I mean, it's saying kind of what you said, it's just a simplified, you need a source device, and then you need the channel that goes between the source to the destination device. And the channel would either be like a fiber optic cable, an Ethernet cable, wireless, right? You could do wireless. So you've got those three things, source, the channel, and the destination. And so that part of it, module 3 is actually going to dig into that a little more. Yeah, it digs into that a little bit more. So.
A lot of this module is like kind of just the bare bones of like what is a server,
Yes.
and then like client, and then firewall. What is
Yeah.
you know the bare definition of that and such.
Yeah, I think that's a good way to describe it. Like it starts to give us some definitions for some of the terms that we're going to see. And a lot of the terms we've seen in our own lives. Now, whether or not I actually knew what they were is another thing. But again, I think we've heard the word server before. We've heard the word client before. But if we've never used it in our everyday life, maybe we don't know exactly how to apply it. So I think this module, again, it's taking vocabulary and it's just starting to give us some vocabulary to use as we're starting to talk about everything. Yeah, yeah. Yeah, thank you.
Most of your WAN media is is going to either be copper or optical. So, every once in a while you'll get them where they have satellite and radio. But those are the different ones that'll look like on the thing. But the copper, fiber, and wireless are the three types.
Yeah, the biggies, right?
Yeah.
What is the 0 day?
Oh,
A zero-day attack is an unknown vulnerability exploited by a hacker.
I don't remember. The text did say when you do this access. I'm guessing the definition is the day or the
Well, right, like, okay, Microsoft's recent hack was a password hack, but there's other ones like the one that blew up the Iranian centrifuges that were
water system or whatever it was.
enriching the uranium. They took advantage of something like, what was it, 14 or 47 or some ridiculous number of zero-day vulnerabilities. That was pretty rough. Here's a security flaw in your software, Microsoft, that allows me to elevate my credentials to do something I shouldn't be doing that you don't know about, Microsoft.
Yeah, that was I'm like, okay, that's a little too far.
As soon as Microsoft identifies that was how they got in, that is where everything before that was day zero. So it's usually discovered by black hat hackers who exploit a system. On a rare occasion, it's white hat hackers working for Symantec or something like that. Very rare. Black hat is intent of negative, like I'm going to hack into a company to steal information. White hat is the company paid me to network penetrate their network.
And then there's like,
There's
a gray
where it's
hack
like,
where you don't pay me to do it, but I'm going to hack in, and when I find a vulnerability, I'm not going to exploit it. I'm going to tell you about it.
and then when you ignore it, if I go to the press, you'll prosecute me through the DOJ like they did for the AT&T exposure.
Yeah.
Lots of complications to
My advice is don't do it unless you're being paid by the company to do it. What do we got?
Aims to identify threats that are already in your system. That doesn't seem right, though.
An IPS device? Yeah.
Oh,
So IPS that's an intrusion prevention system or an intrusion prevention software. So to identify threats that are already in your system.
That's what it made it seem like when I did the
Oh,
reading.
things to identify. Oh, okay. So something that can identify a threat to your system is an intrusion prevention system.
So I was
Yeah.
right. Okay.
Yeah. Yeah. So next time, go back and forth. Yeah. Next time, go back and forth. Right? You ask a question, then you ask a question. You ask a question.
Because we went through all of mine, and I'm like, okay, no, you do your.
Yeah. Next time, go back and forth. So then you have. That's good. That's the goal. That's the goal.
I saw it on the news. Yeah. Sorry, we got sidetracked.
What do you got? You had a good question?
Oh no, she had asked me what I was studying to do, and I asked her, and then she had said cybersecurity, and I asked her, "You guys, I saw something on the news about like a new lab here or something."
There's a GSOC here. Yeah,
that what it
Security Operations Center. Yeah.
Saying it was some kind of internship or something.
They have 2 interns. Yeah, they
That's why
have.
I didn't know what it was.
I think only 2. They might have a couple more, and they'd like to hire more. But I mean, you know, it's limited by equipment and by the amount of work that they have.
Right.
Yeah. So learn as much networking as you possibly can. 82% of all cybersecurity people start out in networking. Because that's where mostly you're going to cut your teeth and learn about the network, because what cybersecurity is protecting the network, right? Learning about the network. So yeah, you want to do another good job isn't getting into a NOC, a network operating center, just like a GSOC, except you're not as much on the security side, but you're still monitoring and checking all of the network and, you know, making suggestions for security. It's hard to get into cybersecurity as an entry-level person.
Right.
So that's why I always tell my students, like, get a CCNA, get a CompTIA, get a, Security Plus, like, do all that so that you can better your chances of getting into cyber early. It's, the industry is working on that. Like, they're trying to create more entry-level cybersecurity jobs. The problem is you have to draw on so many different so much different knowledge that it's just hard to have an entry-level job in cybersecurity. So that's why I really want everyone, get your CCNA, because that will be the first thing to get you in the door of a GSOC or something like that. So, yeah. So,
Good to know.
yeah, I think so too. All right, so
Your company owns it?
everyone ask one more question. Okay? So everyone ask one more question. And if you've already done all yours, make one up. Everyone ask one more question.
Some common internet connections for businesses. Like how, when they go and get internet from somebody, how is it coming in? It's usually through one of four services.
Ethernet over fiber.
Like, not like Cox or something like that, right?
Well, there's like Metro Ethernet, Business
Metro.
DSL, satellite,
Point to point.
dedicated line.
Oh, so it's like specialized version of what we private.
Right, whereas we have Cox Home Internet, they have business levels of things.
Right.
Depending on the business size.
Okay, so it's
Sonnet
like
rings.
basic satellite, they get like super space.
Right. Yep.
That's why I was drawing blank. I was like, this is like the same, but just higher tiers.
And sometimes their satellite network is a private satellite network.
All right. Yes. You've got your phone in the car?
I can't get into Ken.
Yeah. Yeah, go ahead and go get it. Yeah.
Kind of needs that.
Yeah. I know, that's a bummer, right now? Okay. So go ahead and go back to your seat. For your flashcards, make sure your name is on them and that you have them numbered and the module. So like the first page, the first one, make sure your name is on it, what the module number is, and then make sure each card has a number on it. Okay, and if yours have already been graded, you don't need to do anything with them. If they need to get graded, we're going to pass them back to Chase. Okay, we're going to pass them back to Chase. Okay, I heard some really good questions, so I think that's good. So you kind of have an idea of what this is going to look like going forward. Okay. Next week, Module 3 flashcards are due on Tuesday. Oh, they're actually due Monday night, but remember, bring them Tuesday. Okay. We'll probably do them on Tuesday, but for sure we'll grade them on Tuesday. And if we don't get to them Tuesday, we'll actually do them on Thursday. So always just bring the module that we're working on. Okay, just have it with you, all right? Just have it with you, okay? So when you're done, go ahead and hand them in to Chase, and then you can go back to your seat. Did everybody meet the person that you were partnered with? So if I were to ask you their name, you'd be able to tell me?
Yeah.
Yes? Daniel? Okay. Brody? Okay, good job. Kevin?
Yes, Jason.
Okay, nicely done. Do you go by Lou?
Well, you can call me Kevin, but that's how you remember me already.
I already do, but if you go by Lou, I can remember you.
Yeah, it's just too many common names. Kevin's such a
Oh, Kevin is a kind of common name too.
yeah.
Okay.
Like at work, everybody just calls me Lou instead of like Kevin from accounting or morning Kevin.
Right, coffee Kevin.
Lunch Kevin.
Get it. Like,
Yeah, because your name's kind of common.
Yeah, there were 4 Jasons in my 4th grade class, 6 in my grade at my school. And yeah. And then military is like, okay, you just go past. Boy.
Did I send you home with a handout? What handout? Oh, good. Okay. And some of you owe me that. Okay. Let's just go over it. Yeah, let's just go over it. I just wasn't sure which one it was. All right. So does everybody have it out? Okay. So let's see. If we start with this page, 172.56.70.5/12, that's our IP address, right? That's the IP address. And so let's see. Let me put the IP address down. /12. So what network does this one belong to? So what is the network that it belongs to? 172, somebody. 48.0.0/12. Okay, I agree with that one. Okay, and so let's see, the next one we had was a 192.250.200.64/16. A pretty easy one. Oh, let's see. My bad. I'm doing this wrong. Hold on. Let me rethink my. I'm not doing it wrong. I just want to do it different. Okay. So the IP address, I just want it down a little lower. 192.250.200.64/16. Gabby, can you give me the network address for this one? Yeah. Have you started to notice that the ones on the octet boundary are kind of easy? You know, because like all the ones are in the first 2 octets and then all the zeros are in the last. So those are kind of the easiest ones. Guillermo, how about the third one? This is the 160.24.170.27/17. Can you tell me what network this address belongs to? Good job, 128.0/17. Did everybody get that? Okay, did everybody get that? We're just going over this, Marcus. Did you find it? Yeah. Oh, good, okay. Okay, so the next address is 10.10.63.24/23. So what network does this belong to, Matthew? .0/23. That looks good to me. Did everybody get that? Again, we can go over them in more detail if we need to, so just call it out. We'll go over it. Yeah. How do we get 62? Okay, so what we want to do is start using the things that we know. So if we have a 23, what octet is it in? A 23? That might be your mistake. 23. It's in the 3rd octet. 23? So remember that octet boundary is 24, right? So if it's 24 or lower, it's going to be in some of the upper ones. If it's 25 or bigger, it's in the 4th. Like you kind of have to think of that. You got it, Lou?
Yeah, I understand now.
Okay, perfect. Everyone else good on this? Okay. And let's see, we've got another one. So then we have IP address. 63.63.27.200/26. Okay, so what network does this one go to? Caesar, do you have this one? No. Okay, Brody. 63.63.27.192/26. Okay, did everyone get that? Because we can bid it out if we need to bid it out. So we're in the 4th octet, right? If you bid out the 200. Okay, and we've got one more. The IP address for this one is 192.168.200.200/22. So we want to know what network does this belong to? Ozzy, you got it? Yeah, .200.0/22. Okay, everybody get that? Yes, yes, yes. Okay. So again, what that means is that this IP address would be on a host device somewhere, and it would belong to that network. Okay, did everybody do the assignment where you looked up your own IP address and yeah? Yes?
I messed up freaking boundaries while I was laughing, so it was the easiest one. I looked at it like, how did I get it wrong?
Was yours on the octet?
Boundary, and I changed the 4th octet. I'm like,
Yeah. So most of you, who had a 192 address? Raise your hand high if you had a 192 address at home. Okay. What about a 10? Did anybody have a 10? Did some of you not do it? Is that why you're not raising your hand? Oh, you forgot what it was. Oh, maybe you didn't do it in time?
No, I just went home, went to sleep, and the next morning I checked, it was like, oh, you're locked out now.
What day was it due?
what's the day after? Yesterday?
Yeah, I think it was due yesterday.
The day of, was it yesterday or Wednesday?
No, I think it was due before class. I think it was due last night. I'm going to look. Find your IP address, default gateway, and subnet mask. It was due last night at 11:59 p.m. All right. Most of us probably have a 192 address, right? And not always, but I would also say that most of us are probably a /24. Every now and then the ISP will do something weird and give you a 23. Huh? Yeah, if you have a /24, 254 usable, right? Yes? You had a 20. Like a 1, it didn't start with 192? Okay. Did it start with a 192? Usually it starts with so most home networks are going to start with a 192. A lot of business networks are going to start with a 10. And then things like these school labs are 172. Okay, a 172. So let's everybody go ahead and do an IP config. Okay, do an IP config in your command prompt. And I want you to get your IPv4 address and your subnet mask, and then I'd like you to figure out what your network address is. Okay? So get your IPv4 address get your subnet mask, and go ahead and figure out what your network address is. And if you're like me and you also have another one on the virtual machines Ethernet, figure out the 172 as well. Go ahead and figure out what that network address is. So you're going to be figuring out 2 network addresses. You should, oh, you might not. If you're in that, you won't see the 172. Let's make one up. When you've got the network address for your computer, just pop your hand up. So I know that you've got it. Okay, thank you. You got it? Okay. Got it? Good. Okay. Thank you. Again, if you have a 172 address up there too, go ahead and figure that one out. Okay, so let's go ahead and do this one, and let's see what we learn about this. So we're going to do the shortcut. Okay, so 255 tells us what about this very first octet? Yeah, it's in the network, right? So we know that that's in the network. Okay, and then we've got that over here too, 255. What about our second octet? It's also in the network, right? So 204. And then, so this third octet is where the change is happening, right? So let's just, I'm going to bit this one out so we can see it, okay? Let's bit it out so we can see it. And so let's see, if I bit out 68, Matthew, can you call out 68 for me?
0, 1, 0, 0, 1, 0.
64.
Sorry,
0, 1, 0, 0. Okay. And then what do we know right here about the fourth octet where it's got this 0? It's all host bit, so it's off, right? So I know that this one is a 0. Okay, and then 254. Angel, can you call out 254 for me, just with the ones? 10 for 254 on the subnet mask. Remember, the subnet masks are all ones followed by all zeros. 1, 1, 0, right? Okay, so this is the part that's the network. Do we agree? Like wherever the ones are, that's the network. Okay, so what is this number? It's still 68, right? It's 68, but I like to just do it to prove it, right? So 10.204.68.0 slash what? 23. So that's my network address, right? So here's 10.204.68.0 slash 23. That's the network. Everybody get that? We all have that network? Okay, so let's just kind of visualize what this might look like. Okay, so I've got a router, right? And let's say over here, I've got this switch. I might have a bunch of switches because it's probably a pretty big network. Okay, so it goes like this, right? And then we've got a student computer, we've got a student computer, student computer, student computer, right? We've got all these student computers. Okay, so Angel, give me what your IP address is. Yeah. You don't have a 10 address? Chase, will you please take a look? Okay. Matthew, what's your address? 39. Okay. Guillermo, what's your address? 10-204-68-79. What is it? 10-204-68-79. 79. So that's a .79. Gabby, what's yours? A dot what? A .90. And mine was a .96. Okay. Caesar, what's yours? A dot what?
48.
A dot 48. Lou, what's yours? 170. A dot 170. Brody, what's yours? A dot what? 260. Okay. 16. 216. Marcus, what's yours? A dot what? A dot 68. Okay. So do you see how all of these IP addresses belong to this network? Do we follow that? Okay, oh, hi Orgil. So they all belong to that network. That's why it's important for us to know that, okay? Now, we also need to have, there's two addresses that we don't count as usable. The network address, what's the other address? Yeah, that broadcast address, right? The broadcast address. And you should have watched a video about that and how to find the broadcast address. So what would happen is if this network needed to broadcast a message to every single device on the network, it would use the broadcast address, which would be 10.204.69.255/23. So if it needed to talk to everybody, it would broadcast a message out, okay? So let's say that that's for all of the students, right? Like all the classrooms. Let's say this is for all the classrooms. And now let's say that we needed to set up a network for the student union, okay? What would the next network be if I wanted to set up something for the student union? 70.0. So let's do it, okay? So a 23, what does it increment by? It increments by 2 in what octet? The third octet. So that means we have to take 2 and add it to 68. So we would add it, and that's how we could get another network, right? So we could get a whole nother network, add more devices, and its network would be 10.204.70.0/23. What kind of subnetting is that when we always find the same size subnet? Equal subnetting. Equal size subnetting. If we just keep subnetting and subnetting and subnetting, the networks are all the same size, right? So today we're actually going to learn about variable length subnetting because it isn't realistic that every network is the same size, right? And so also there's this waste of IPv4 addresses, and so it allows us to conserve addresses and stuff like that. So we're going to learn variable length subnetting, all right? Let's take a break. First of all, we're going to come back after break, and we're going to do a little bit of hex review, and then we'll do something else, and then we'll go into variable length subnetting, okay? So let's take a break at 7:03. Why don't you come back at 7:10? Orgil, did you bring your flashcards? Can you turn them in if you didn't already? Turn them in on Tuesday? Just give them to Chase. Nope. Just hold on to it. All right, how many hex values are there? 16. How many hex values are there? How many hex values are there? Thank you. All right, let's count them out, starting with 0. 0. 0, 1, 2, 3. A, B, C, D, E, F. Got it? Jeez. All right, so let's just warm our brains up a little bit with a Kahoot.
How did you guess? Oh my gosh. Professional guesser.
I love me some Kahoots. So we're going to be converting hex to binary. You might want to have your table out if you think that will help you.
Yeah, it's the music before. Yeah, before numbers. Yeah, I had to think about it. When people load it, you can see the icons changing.
Yes, yeah. Who am I missing? Chop, chop, Daniel. Thank you. So we're converting hex to binary. Oops. Tricky. So 0 and then B is 11, right? Last one. Good job. Or Gil, excellent. Jason. Drum roll, please. Angel, nicely done. Nicely done. Got some runners up. Okay, let's do the next one. This one is decimal to hexadecimal. So you got to bit that out first and then separate it, right? 192. You got to bit that out. So let me, again, I'm just going to show you kind of what I do to maybe make it a little bit easier. So now I can bit things out in my head fairly good, especially some of the ones that we use all the time. I can't do them all, but 192 I can. So I know that 192 looks like this. Okay, so right off the bat, this hex value is going to be what? 0. So I just immediately eliminate these two. And then I don't have to deal with 4 answers, right? I'm just dealing with 2 answers. Then I just am looking at this, which is 12, right? And that's C. So when I can eliminate stuff, I do. I just eliminate stuff. When you take any type of a certification exam, at least half the answers are going to look good and they're going to look right. Like on the CCNA, they'll do several multiple choice. Most of them will be multiple choice, and often there'll be 5 or 6 answers, not just 4. And at least half of them will look really, really good. So you want to just start eliminating things and using terms to eliminate stuff like, oh, I know that term doesn't belong to this type of a question, which will make more sense as we start learning about the OSI model. But start practicing elimination. Like, how can you eliminate stuff to narrow down your choices? It'll make things a little easier. see, 225. Does the elimination work? It does. At least for one of them, really easy to eliminate, right? Ooh, should we do this one? Here, let's do it. Okay, so 225. So if you know what 224 is, that's 224. Now we just add the 5. So 224 plus 1 is 225. So we're going to look at this value, which is what? So 8 plus 4 plus 2. 8 plus 4 plus 2, 14. So then how do we write 14 in hex? E. Okay. Now let's look at this one. 0001. What's the value? 1. How do I write it in hex? 1. See that? Yes? Yeah? Okay. Yeah, you can do that too. Yeah. I'm not as good at subtraction in my head as I am with other stuff. I think if I were to practice, I'd be better. So you're going to bit this out, split it in half. These are two easy patterns, right? Yeah, so let's do this one, because this one's not too bad. It's two easy patterns, which is why we start in week 1 learning the easy patterns, because the easy patterns help everything. They help us figure out hexadecimal. They do everything. So if I do 170, that's an easy pattern of what? Right? So it's 1010, that's 160 plus 10, there's 170. So we would write out 170 in binary. Now we look at this by itself. And what does that equal? It equals 10, and in hexadecimal, 10 is written as an A. And this one is the same thing. This is a 10, and in hexadecimal, we write that as an A. So the answer is AA. Okay? If you're missing them, just make sure you know why you're missing them. Okay, and then again, also let that inform you that you might have to spend some extra time this weekend with these types of conversions, okay? You know, maybe you've got binary to decimal down, or maybe you've got binary to hex down, or maybe you have hex to decimal, whatever, you know, but work on whatever it is that you don't have down. So convert 12 into binary. job. All right. So Gabby, Matt, and Orgil, nicely done. We've got some runners up, Jason and Daniel. Excellent. We're going to do one more. So we are going to convert hex to decimal. So we're going the other way this time. Okay, we're going the other way. So you're going to take the hex value, make it binary, and then figure out what those together become for decimal. Got it? Okay. Okay, so you'll convert the C to binary, convert the 1 to binary, and then look at that octet to figure out what the decimal value is. Excellent. Not bad. Good job. Right, so you take that 7, take the hex value number 7, right, which looks like this. And then the hex value number 4, which looks like this, right? And then you look at it as a whole, and that is 116. Nicely done. Joey, nicely done. Brody, good job. Drum roll, Gabby, nicely done. Runners up, Orgil and Waldo, good job. Again, if you're missing some, just make sure you know why, do a little practice. If you are getting them all right and you're being methodical and slow, that's awesome because slow is fast. All right. Okay, so I have published these. Okay, so we are still in week 2, right? We are in week 2 in class activities. It is Thursday. So we've done our flashcards. We just did these 3 Kahoots. What I'd like you to do is mark that we did them in class, right? So go in there and mark that we did them. Just take this quiz and mark that you did it in class. Okay, and then do this 4-question quiz. Okay, just gonna So mark the Kahoots and then do the quiz. So week 2 in class. Did we turn that, did I? Yeah, we collected that. Yeah. Do you not have any points?
I'm not sure what that means.
Look at the grades. See if it's in grades, because we added the points manually. But just, yeah, make sure you have the points in your grades. If not, then we'll do it. We'll take care of it. Yeah.
Class activities on the 23rd, but I mean, there's one that's not crossed off for class activity.
Which one? Was that Tuesday? Was it the hex worksheet? So we entered that one manually, so you might not see it crossed off. Look in grades and see if it's in grades. That's the worksheet. That was the worksheet. So if you got my initial on it and turned it in, check in grades. Right. That means you didn't hit the true or false because we just collected the worksheets. We collected the worksheets. It wasn't open for you to hit the true or false because I only gave credit if you brought it in on time and had the initials on it. So it should be. If it's not, let me know and we'll fix it. We'll fix it. Okay. I'm going to publish one more thing. And it's a survey. Okay, so if you go ahead and refresh your screen, it's a survey. I just kind of want to see where we're at as far as the numbering systems that we've already gone through. Okay, binary to decimal, decimal to binary, and some hexadecimal, and the subnet mask. So if you refresh your screen, you're going to see that survey. Got to gauge where we're at. The survey, it should be in the week 2 class activities right under the quiz we just did, I think. Do you see it? Oh, you already did it. Okay, so it's in there. Yes, survey. The one that says survey. All right, everybody done with the survey? Yes, 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 okay. Okay, so what we're gonna do is we're gonna just keep pulling all of this together, right? We're gonna pull everything together. We talked about the subnet mask, prefix length, and then we talked about equal subnetting, right? And the equal subnetting is when we figure out what the subnetworks are, right? The subnetworks, and they're of equal size. And what do we do to find the next network? Somebody raise their hand. Brody. Yeah, if we want to find the next network, what's the process? Okay, so how do I find the magic number? Yeah, so I'm going to look for the last network bit inside of the subnet mask, and then what?
And once you get the magic number, you would add to the octet that the last network bit is.
Right. Okay, so I find the last network bit, and how do I know what that increment is? How do I know what the magic number is? I have to look at the what? Someone? Caesar? No. Yes, Lou? You just said it. I heard it over here. The positional value, right? We look for the positional value, and then we take that value and we increment it. We add it in the octet where the last network bit is, right? We agree? Okay. So what we're going to do today is we're going to add on to this, and we're going to do it the long way, and then I'll show you shortcut ways too, like we did the other day, okay? And then that way you'll be able to do it whichever way makes the most sense to you, okay? So what we're going to be talking about next, everyone needs to be writing it down, typing it into a notepad, adding it to your mind maps. Doesn't matter to me, but when we leave here today, I need to be able to see that you've captured something that I was talking about, okay? And if you don't already, have out your table with the 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024 with the matching subnet masks. You're going to need that today. And you might need a positional value chart. So we're going to pull it all together. We're going to button it up. Okay, so everything we're going to talk about today we've already been talking about. It's just we haven't necessarily applied everything, right? So we're going to be working on, we already know how to find the network address, right? Now, we've talked about the broadcast address. So we're going to learn how to find different addresses that are within the network. And we're going to find the first, the last, and the broadcast address, okay? So we're going to be able to find the first address, the last address, and the broadcast. So the network address and the broadcast address, what's significant about them? Yep, it's the very, very, very last one, right? And the network address is the very, very, very first one. Do we agree with that? Okay. Jason? They cannot be assigned to what? A host. They can't be assigned to an end device. So that's really significant, okay? We can't use the network or the broadcast to assign it to any type of a device. So what we need to know as network administrators, as security officers, is we need to be able to figure out what are the addresses that we can assign. And that would be the first address, the last usable address, and everything in between. Kind of like when we were calling out what each individual's IP address was, right? Everyone had a different IP address, and it's because your IP address came from a list of usable addresses. So it's important that we know what addresses belong to the network and which ones are usable. So we know the network isn't usable, we know the broadcast isn't usable, so we're going to talk about everything in between and how we find those, okay? Because it's the host bits that get manipulated that make up those usable addresses. It's the host bits that get manipulated, okay? And another thing, the first usable address is often used on the device that we call the default gateway, okay? It's not 100%, but it's kind of a rule of thumb, or it's an industry accepted process, and that's to use the first usable address on the default gateway. And next week, we're going to start talking at length about the default gateway, and that'll be something else that we talk about and really dive into deeply so that we can understand that. Okay. Now, the last usable address, again, I'm just going to throw out what's common, but it's not like, oh, it has to be like this. It's something that's common. A lot of times they'll put like the last usable address on a printer or on a server. It's a usable address that can be accounted for, so it's common to do that, but it doesn't have to be that way. They're usable addresses, they can be used on anything, but again, just kind of what's common, okay? So if we kind of break these different terms down based on host bits, okay? I want you to think of them in terms of the host bits. So with the network address that we've been learning about, that's when all those host bits were turned off because of the way the Boolean worked out. It always works out that the host bits in a network address are off because it's a network address. It can't be used on an end device. So they're always off, okay? The host bits will always be off. Now, if we're talking about the very first usable address, and again, like let's just think about, like if we think about a network address right now, we'll just use kind of a simple one, like let's use 192.168.10.0/24. So these over here are what kind of bits? Everybody? Yeah, these are all the network bits. And this guy, because it's a 24, these would be host bits, right? And so what the first usable address is, so this is what this fourth octet looks like as the network, right? This is the network. Well, if we want to figure out what the very first usable address is, what this says is that all of the host bits are off, except which one? Yeah, that very, very last one. So that would make the first usable address 192.168.10.1, okay? Now, it's the /24, okay? So the definition of the first usable address as it relates to the host bits is all of the host bits are except the last one, okay? So the last usable address is when all of the host bits are on except the last one. So if I were going to be doing the last usable, right, I would turn host bits on except the last one, okay? And then lastly, the broadcast, what do I do with the host bits? They're all on because I'm trying to get out to everybody. If I'm broadcasting a message, that means that the message is going out to everybody, okay? So if you can imagine, it's everything that falls between the first address and the last address that is usable and can get assigned to one of these devices, okay? So if we have a /24, how many usable addresses would we have? 16. I don't hear very much confidence. How many usable addresses would we have? I think I'm counting wrong. 32, 31, 30, 28, 27, 26, 25. What did I do on? 1, 2, 4, 8. Ay, ay, ay. I cannot multitask. Okay. 4, 8, 16, 32, 64, 128, 256. So a /24, how many? 254. So what they're telling us is that between one and the last one, there's 254 available ones. And how does that get there? Well, it's every single combination of bits, right? So it would be literally, these bits are just getting flip-flopped and doubled up, right? Any and every combination. until we come up with 254. So it would be the dot 1, the dot 2, the dot 3, the dot 4, the dot 5, the dot 7, the dot 200, the dot 201, the dot 220, the dot 250, 251, 252, 253, 254. Every combination of ones and zeros to get to that. Does that make sense? Okay, perfect. So if we just kind of look at it and look at this as an example, so here's our IPv4 address. We can find the network, right? So we already know how to do this. 192.168.1, what are all these bits? They're all hosts, so they're all turned off, right? So there is our network address. Notice that all the host bits are off. There's networks bits, there's our host bits, and so our network is 192.168.1.0, right? We follow that, okay? So let's look at the first usable address now that we know the network. So here's our network address, right? Here's all of our host bits. So what I'm going to do now is I'm going to turn all of the host bits, what? Except the last one. So they're all going to be turned off except the last one. So what's the first usable address? Yeah, 192.168.1.1. Got it? Okay. So now we're going to find the last usable address. So this would be the last address in the network that I could put to use and add it to an end device. We're going to do the same thing. Here's my network bits. Here are my host bits. Now I'm going to flip them around. So I'm going to turn all of them off except, I'm going to turn them all on except the last one. So what is my last usable address? 254, right? It's going to be 192.168.1.254. So I now know that anything between the number 1, starting with the number 1, up to 254 can be assigned to an end device. Okay? And then lastly, the broadcast. Network stays the same. Host bits, right? What can I do with these host bits for a broadcast? I flip them all on. I flip them all on. So what is my address? Everybody, 192.168.1.255. Okay? So now we have figured out the range. And then that, depending upon the size of the subnet mask, we have more hosts or less hosts, right? So if we keep in mind here, the bigger the subnet mask, the fewer the hosts, right? The smaller the subnet mask, the more the host. So it gets to be a lot, right? Okay. Network, there's our little range. Look good. Network is here. You can use all, yeah. So we can use all of these addresses. So the first usable address, if I'm following industry standards, what would I apply it to? Yeah, I would apply it to the default gateway. Who's familiar with the term default gateway other than the times that we've talked about it in class? Okay, I know you are. Brody, anybody else? A little bit? Did they go over it in A+? You probably did a little bit. Brody, can you add anything to that? What do you think it is? To the LAN. Yeah, so let's go ahead and just add this to our notes now since we're going to start talking about it. So there's kind of 3 things that describe a default gateway, okay? There's more or less 3 things that describe a default gateway. So first of all, it's an interface on a router. So it is a router, but more specifically, it's the interface on the router, okay? So it's an interface on the router. The other thing is that interface has an IP address from the local area network, okay? The default gateway will have an IP address from the local area network. Default gateway, it's a term that only refers to LANs. Okay? The last thing is it serves or functions as the exit and the entry point for the LAN. The exit and the entry point for the LAN. Okay? So then there's our, wait till everyone's done. So if I ever say what's the default gateway, those are the three things I'm looking for. It's not enough to just say it's the router, because the router might have other interfaces on it, it might have other jobs. So you have to say it's an interface on the router that faces the LAN. So if we look at this example, right, we've got our network, and then here is just seeing the different addresses on the network. The .1, the .2, the .33, the .4, 100, 250, all the way up to 254. Okay, makes sense? Perfect. Let's see, now we have the full range. So what would the next network address be? What would the next network address be? I know you know. .2. Yeah, .2. Okay, it would be .2. What would the next network be? .3. And we know that because we can use the magic number from where that last network bit is, right? We know that because of where the last network bit is. Okay? All right. And that is called what kind of subnetting? Equal subnetting. So equal subnetting. So we're going to put this all together and we're going to start doing variable length subnetting. Okay, that's where we're going to go after this. So here's an example of a network. So here's my default gateway. It's an interface on a router that faces the LAN, right? Each of these have to be a unique IP address. They cannot share IP addresses, okay? An example of the last usable, we put that on a server. And then here's all my unique IP addresses. They range between the first and the last. And the broadcast, well, that would be able to go out and communicate with everybody. Anyone who's on that network would be able to receive the broadcast, including the default gateway, because it's on the network, okay? It's on the network. All right, so one thing I want to point out is it's just counting, right? It's just counting. So if we look here, we've got a network address of 0.0. The first usable address, we turn on the very last host bit to get a .1. Then we're going to manipulate the bits to turn on all the host bits except the last one to get the last usable. And then we turn them all on to get the 255. Okay, so it's just counting. Now we get the next network. And we do the exact same thing. It's going to be a 1.1. And then the last usable will be a 1.254. And the broadcast will be a 1.255. Okay, so it's just counting. It's just counting. All right? So let's try some variable length subnetting. Oh, there's an example of a network, what it might look like. Okay, there's one network, there's a next network, and our next network's a little bit smaller. This one's really easy to see, right? It would be like the first usable address, 2, 3, 4, 5, 6. Okay, just what it might actually look like. Here's our default gateway, right? We're giving it the first usable address. Okay.
3 LANs, right?
Yeah, there's 3 LANs. Yeah, right? So that's good. There's 3 LANs. Here's our sales LAN. This is the default gateway for this LAN. We've given it the first usable address. Oh, I actually see a mistake. Let's not look at this anymore. Do you see the mistake? Who can see the mistake? Yeah, man. Okay, let me see if I can walk us through. So here's our first network, right? 10.10.10.0. And here's the first usable address right there. Right there it is for this network, right? The default gateway. And then let's see, human resources. Here's human resources. What's the first usable address for human resources? Right here. What's the first usable address for human resources? .9, but that says .1. It's .9. See that? See, the first usable address won't always be a 1. It won't always be a 1. That only happens when you have a /24, a /16, or a /8. Okay, so what about marketing? If this is marketing, what's the first usable address? 17. So this is a .17. See, there's the default gateway, and then we have 18, and then we've got 22, 29. So everybody see that? Okay, so what if I'm a network administrator, and I go in to start adding an IP address to the default gateway, and I just assume it's a .1? What's going to happen to the marketing network and the human resources network? It's not going to work. No one gets paid, right? So it's important that we understand how all this works so that we can apply the right addressing. Does that make sense? Okay. So again, a good application of why it's important. Okay, so we're going to walk through one together, and then we're going to take a break after that, and then we're going to come back and we're going to do more, okay? So let me pull up the VLSM, yes. Okay, so I'm going to hand this out. Please do not work ahead, okay? Work along with us, work along with me. So, and the same thing applies with what we've been doing. Can you help me pass these out? Can you help me pass these out? I want you to bit everything out today, okay? I want you to bit it out. Even if you know how to do the binary and the decimal, just bit it out today on these examples that we do. And then you can start to change that, okay? If you know how, if you're good at binary and decimal, that I'm happy about that, but I want you to bit everything out so that you have a good example at home, okay? Okay, good. Okay, so what we're doing, this is called VLSM, Variable Length Subnet Masking. So up to now, we've only done equal subnetting. Okay, we've done equal subnetting, which isn't very realistic. If you think about the school here, we have a lot of different departments. It's like we have a wireless network, we have some cameras, we've got virtual machines, we have classroom computers, we have lab computers, we have a student union, we've got administrators. We have all kinds of things, and we're not all on the same network. We're divided and we're put on our own networks. And there's a lot of benefits to that, one being security, one being if somebody makes a mistake and takes a network down, it doesn't take all the networks down, whether that's from an internal mistake or somebody externally messing with your network. Okay, so it's a good idea to create smaller, what we call broadcast domains. Smaller networks, okay, smaller networks. So what's more realistic is that we do variable length networks, okay? And so that's what we're going to walk through today, all right? So here's our starting network address. So imagine that this is the address that the ISP has provided us, okay? So this is like the address that the ISP has provided us. And so from there, I pay a dollar amount. Maybe I say, hey, I'm opening up a small business. I think I'm going to need about 200 or 300 addresses. And so they'll say, oh, okay, well, here's a starting network. And this is very high, very generic example. And so they'll say, go ahead, here's a 192.168.0.0/24. Start with that address and do whatever you want with it, okay? Perfect. So I've got a LAN that I need to have 60 hosts on it. I've got another LAN where I have 30 hosts, and then I've got a LAN C with 15 hosts, and I have a LAN D with 5 hosts. Okay, who knows what I'm going to call those networks? You know, maybe it's a sales, a customer service, an IT department. So first of all, what's one of the things you notice about the order of those numbers? Largest to smallest, okay? So that's the first thing I really want you to remember about VLSM. You always have to go largest to smallest. There is never an exception. There is never an exception. You will always go largest to smallest. And that's because you've got to think about the bigger networks first, so you don't have to rob from Peter to pay Paul down the road, okay? Now, something that we're not going to do today, but we'll do it in a couple weeks, is if you're a network administrator, something you might think about is whether or not you'll have a change in the size of your network. So if I'm a new company, and let's say I hire 100 customer service reps, my goal would be to grow, you know, so I might think about whether or not, in a year, I might have to have more. So I would maybe take that into consideration, but we're just going to learn how to do it straight through, okay? So the first thing is we're going to kind of fill this out. So if I needed 60 hosts, what prefix length or subnet mask would take care of 60 hosts? Okay, a /26. So we're going to pop a /26 in there. Why is it doing that? Okay, it doesn't like a slash, so I'm just going to put a 26. Okay, so if I have a /26, what octet would that be in? My last network bit would be in my 4th octet, right? And so what does a 26 increment by? 64. My brain thinks so far ahead that I can't stop it. Okay. So we've got that required information, right? Let's go ahead and do the others. So we're going to fill this all out. So a 30, what prefix length or subnet mask takes care of 30? A 27. What octet does this fall in? The 27. 4th, because it's bigger than 24. And what is an increment for our 27? 32. Okay, let's keep going. 15. Let's see. So if you have 15, you need 15 addresses. If you take a /28, what do you have to do with this 16? You have to take 2 away, which leaves you with, so do you have enough? So what do we need to do? We got to stay with the 27, right? So that's an important thing to keep track of. If you don't, you got to go up to the next one, the next biggest host. Okay, octet and increment. 32. Okay, and then we've got a nice little network with 5 end devices. Prefix length? 29. Octet. 4. Increment. 8. Okay, so everyone get that filled out. So we're plugging in all the stuff we already know, all the stuff we've been learning about, okay? Okay, so the first network address that we begin with, because we need to find, like LAN A needs its own network. LAN B needs its own network. LAN C and D, they need their own networks. So we have to find a network address for each of them by splitting this one up, like dividing it like a pie, you know, like we're giving out cake or something. So what we're going to do is you're going to always start with this first address. Okay, so we're going to start with the 192.168.0.0, but it's going to get a new what? It gets a new prefix length. It gets a new subnet mask. We can see right there, it's going to get a 26. Okay, so it gets a new prefix length. Okay? So you always start with the address that the ISP gives you. It's just that because you've divided everything up, it gets a new subnet mask. Does that make sense? Perfect. Okay, now we're going to do what we know. We're going to do what we've been doing, but it's a variable length. So I'm going to take this address, 192.168.0.0. I'm going to increment it by 64 in the 4th octet. Or you could say I'm going to increment it in the 4th octet by 64, whichever works for you. But we've gathered the information that we need to find what the next network would be. Okay, to find what the next network would be. And we've done that, right? So what would the next network be if I increment 192.168.0.0 by 64 in the 4th octet? 64. And what does it get? It gets a new prefix length. It gets a new subnet mask because we already figured out that if I have 30 hosts, I'm going to use a subnet mask of 27. Okay, so that's where it's a little different from what we did before, because what we did before was just equal subnetting, where every network was exactly the same size. Well, now we're just accounting for the fact that they're different sizes, okay? So we did the same kind of incrementing, it's just that now it's a variable length, okay? So now I need to find the next network, right? I need to find the next network. So I'm going to take this address, and in the 4th octet, I'm going to increment it by what? 32 to find this network. Okay, so what's my LAN C's network address going to be? 96. 64 plus 32 is 96. And what's its subnet mask? It's a 27, right? Because we already figured out that if we needed 15 hosts, we've got to use a 27. Okay? Got that? Okay, perfect. Now we've got one more network that we've got to account for. So I'm going to take my current network, and in the 4th octet, I'm going to increment it by 32 to get the network address for LAN D. So can somebody give me that address? 29, because it gets a new prefix length. It gets a new subnet mask. Remember, the prefix length and the subnet mask is exactly the same thing. If I wanted, I could write 255, 255, 255, 248. It's the same thing. It's just shorter to write the prefix length, okay? All right, we got it? Okay, now I'm going to have you do one more network address because that's going to help us with a shortcut that I'm going to teach you later, okay? So if I take this network address, I've got a 29, so in the 4th octet, I increment by 8. What would my next network be? It would be 192.168.0 dot, and we add 8 to 128, so 136. Do we agree? And I don't really care if it's a 29 or not, you know, it's the network that's important to us. Okay, so do we all have this? And see how all we did was just the incrementing like we've been doing. The only difference is we increment it by a different number depending upon what the number of hosts we had. Okay, is that good? Everyone clear for that? Okay. So the next thing we're going to do is we're going to start figuring out our address ranges. Okay, we've got to figure out our address ranges. And again, what I want you to do is I want you to fill everything in this time. Okay, I want you to fill everything in this time. So 192, what does that look like if I bid it out? 110000. Okay, and then how about 168? 100. Okay, and then the rest are just zeros, right? Except what do I do with the very last host bit to find the first usable. Turn it on. Okay, so I want you to, again, just let's look at this table, because later this weekend, if you have any trouble, I want you to see how to read this. So right now we're figuring out the first usable address. We're plugging in the bits, and it tells you the first usable address. All the host bits are off except the last one. Now personally, I like to draw a line. Okay, and I would recommend that you draw a line. So draw a line. It makes it much, oh, see, I'm drawing the line in the wrong place. Don't let me draw the line in the wrong place. 26. It only works if you draw the line in the right place. So I like to draw the line. So off, 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 on. Got it? Okay, so now I can answer what the first usable address is. 192.168.0.1/26. So you're going to plug that first usable address in right here. 192.168.0.1/26. Okay? And then we're going to do the last usable. Again, do me a favor, even if you're good at the binary, I want to plug it in because I want to be able to see when I come around and look at everybody's that you've got it. 1 0 1 0 1 0 0 0. Okay. Host bits, let's see, are coming up. Okay, so what do I do with the host bits? I'm going to turn them all on except the last one. And you're right, I'm only looking at 6 of them, right? On, off. Okay, that's why the line comes in handy, because even though we're still looking at the whole octet as far as the value goes, it's really important that you are only manipulating actual host bits. You can't just come in here and turn on all of this 4th octet, because these two are part of the network. Okay, so that's why I like the line. I'm much less likely to make a mistake because I'm only turning on the host bits. Okay, so now what is the value of the last usable address? 62. It's 62 because we have the 32 on, 16, 8, 4, 2. The 1 is not on. Okay, so what is it? Okay, 192.168.0.62/26. Remember, you have to have the slash notation. Okay, now, same thing, let's just plug everything in. Okay, what do I do with these host bits? I'm going to turn them all on. Okay. Okay. So I'm going to turn them all on. So I've got 192.168.0.63. Okay, 63. /26, exactly right. Okay. All right. So does everybody see that? Okay, so we're just manipulating the bits. Okay, now this is how to do it using the bits. When in doubt, just bit it out. When in doubt, bit it out. But I'm going to show you a shortcut. Okay, if the shortcut helps, that's great. If the shortcut doesn't help or it makes it more confusing, just ignore me. And you'll learn the shortcut in a couple weeks, okay? But I want to show you something. If you remember, I said it's just kind of counting, right? It's just counting. So a shortcut is to think about just adding one or subtracting one. And that will let us find a lot of these values, okay, once you have the network, all right? So if I know that the network is 192.168.0.0, to find the first usable address, I can just add 1 to the 4th octet, right? I can just add 1 to the 4th octet. So there's that. Now the other thing I can do is once I have figured out the broadcast, I can see here that the broadcast is a .63, right? What happens if I just add 1 to it? I get the next network, right? It's not a usable address, but it's the network. Okay, now if I come back here to the broadcast that I figured out, if I just subtract 1 from it, what do I have? The last usable address, okay? Now, my preferred way of doing things is I always do this stuff and find the networks first. I always find the networks first. And the reason is because if I know that my network is 192.168.0.64, that means that's like the very first address, right? I can't use it on anything, but it's the very first one. Well, if it's the first one, wouldn't the one right before it be the broadcast of the network above it? So same thing, if I subtract 64 from this, look what I get, the broadcast. And then if I subtract 1 from the broadcast, I get that. See that? Okay, so we're going to just try this to see if it works. So we'll do the shortcut on this one, and then we'll prove that it works. Okay? So first of all, if I add 1 to 64, what would it be? 65. So let's just plug that number in. We're not going to bid it out yet, but we're going to come back and bid it out so that we can prove it. 0.65. And what's the new subnet mask? It's a 27. Okay. All right. Now, again, thinking about the shortcut. So we've got the first usable, right? I know what this network address is. So 192.168.0.96. We're in the 4th octet. You have to pay attention to the octets. So if I subtract 1 from 96, what would that address be? 95. And if our thought process is right, that will be the broadcast address for this one, okay, if we're thinking right. So let's just add that in there. And again, we're going to go backwards and do the binary so that we can prove it. 95/27. Okay. And now if I subtract 1 from the 95, I get 94, right? The .94. So let's plug that in. Okay. Now let's just prove using binary if this works. Okay, we're going to prove using binary if this works, okay? So let's see. 192.168.0.64 is the network. So let's plug the network in. So we're going to plug our network bits in. Everyone plug in your network bits first. Okay. Now that's a 0. So our network bits. Okay, .64. So there's our network bits, right? There's all of our network bits. Remember, we've got to get 27 of them. So we've moved the line because we're at a /27. Okay, so get your line in there. These are all network bits. Okay, so what do I do to find the first usable address? What do I do with the host bits? Off except the last one. So that's going to be off, 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 on. Okay. So let's see. Octet number 1 is what? Octet number 2? Octet number 3? Octet number 4. 64 plus 1 is 65. So we proved that our plus 1 works here. Okay, so next what we want to do is we're going to prove whether or not our little trick of +1 -1 works for our last usable address, okay? So same thing, plug in the network address, which is 192.168.0.64. You're plugging that in. Oops, don't watch me, I'm plugging it in wrong. 0. Plug in the network. Plug in the network. This one's all zeros. Okay, and then the network is 01064. So there's my network. Okay, last usable address. What do I do with the host bits? All on except the last one. Okay. Now let's look at our values. So octet number 1, everybody. Octet number 2. Octet number 3. 0. So then we have 64 plus 16 is 80, plus 8 is 88. Am I adding it right?
30, you're right.
Okay. I'm like, yes, thank you. 64 plus 30. So we've got 94. So again, we're just proving that it works. And then lastly, do the same thing with the broadcast, and we should add up to 95, okay? We should add up to 95. So plug it in. Plug in the network. We always plug in the network first because those bits within that network doesn't change, right? It's the host bits that we're going to be manipulating. Okay, here's my network. And now what do I do with these host bits? All on. Okay, so now I've got 31 plus 64, and I have 95. Okay? So either way works. Many years ago when I was first learning this, I always bid it out because I didn't trust it. It's like, let me bid it out. And that's good because that's one of the reasons I got good with binary because I was always seeing the bits, okay? I was always seeing the bits. All right, so I want you to do LAN C, and you can use either method. Do whatever works for you. So take a few minutes and do LAN C, and then we'll go over it together, okay? And write out your bits in the boxes so that I can see them. If you get stuck, call me over. Our line is in the same place. If you've got that one, go ahead and move on to LAN D. Got them all. Got them all? If you want to start doing those, you can. Do you know on the flashcards if they turn in 19 or less, you just give them the number of cards that they turned in? Okay. Yeah. I'm going to add that. I'm going to change the rubric so it's clearer. But you know it, so. Yes. Yeah.
For the last one, 0, 95, right? Got last one got 126. Broadcast
see, that looks right, yeah. Mm-hmm. Exactly right. Yep, it's going to be one less than that one. Mm-hmm. And we're in the 4th octet, so. Okay. Let me look at it.
Do you want me to write it out? Or?
I do, but let me just look and see if I can. Let's see. You forgot your slash notation.
Oh, I did it
Yeah.
for the one, but not the other.
Do them for all of them.
The slash 29.
Oh yeah, and see, get the slash there and the slash there. 29. Yeah, that looks good. It's just your writing's a little hard to read. Add your slash notation, and then work on the next one. Okay. When you're done, just pop your hand up. Let me look at it. Looks good. 27. Yeah. So when you're done with it, go ahead and take a break. It's 8:34. And then be back by 8:40 because I want to get at least one more completely done, okay? So if you need a little break, take a break. If not, that's okay too because I want to make sure we get through the second one.
Mm-hmm. And that's right, but when I'm doing this one, that 30 plus 97 would be 127. What am I doing wrong?
126, you mean? For your broadcast or your last usable? So 96, you add 1, that's 97.
And then I was adding 30 to the 97 to get, oh, I had 30 to 96.
Yeah,
That's
you have
what
to add it
that's
to
what
the, I was like, why are you adding it to that one?
That's what I was trying to figure out.
Yeah.
What am I adding it to?
Yeah.
Okay.
Okay. Okay. So again, if you need a break, take a break, but I want you to then move on to the second one. Want to get at least one more complete done and preferably even more. 96, 127. That looks good. Okay, and then you're going to do that one too, Landy. $129. That looks good. 127, yeah. Looks good. 129. That looks great. Slash 29. 127. Yeah. Good job.
Thank you.
Yeah. Five, 134. That looks good. Yeah. Looks good. When you come back, do the next one. 130. So, no. So, see how this is the next network? We figured out the next network to make the subtracting trick easier. So if you subtract 136, if you subtract 1 from 136, what would you get for the broadcast?
35.
135. But see how you have 136? So fill in your bits and recheck that. And then check that one too. Okay? So get those changed. Okay. Did you get it? So does everybody see why we figured out that next network that we really weren't even using? It's just so we could work backwards to subtract 1. Okay, include your slash notation. So what do you notice about the broadcast address? It's always going to be what kind of a number? It's always going to be an odd number because the 1 gets turned on. And what about the last usable address? It's always going to be an even number, always. First usable address will always be odd, okay? So that's one way to check yourself. Okay, when you're done, do the next page. When you're done with that, do the next page. The only way to get good at this is to do it, and do it, and do it, and do it, and do it. Mm-hmm. Well, where's the last network bit? It's in the third. Yep, so stick to the third. So now you're going to find that the next one we're changing octets. Okay, but don't overthink it. Just follow the formula. Okay? But yeah, we're going to be changing from the third octet into the fourth. Just follow. So this, you might have to bit it out. Okay? You might have to bit it out. So finish the first one and then move on to the next one. If you need help, just call me over. You're moving octets, so. Yes.
So since we're working on the boundary, right?
Uh-huh.
Does that mean I'm working in the fourth or third octet?
Well, so if you look at that, where that last network bit lands, where does it land? What octet?
1.
The 24? The 24th network bit.
It ends on the 1?
Oh, yep, you're right. It ends on the 1 in what octet?
Third.
The third. Yep, so just follow the formula. So it's a 24, third octet. It increments by 1. Yeah, just follow the formula. You got to just trust it. Yes. Is this the second one? Let's see, a 24, third. So we have, no, it's not right. So if you remember, you're always going to start with this address. It just gets a new subnet mask. You've already incremented, so you're already stealing from Peter to pay Paul.
Okay, so rewriting this.
Yep. So follow the formula. So double check this one. So if you have 128 plus 4 plus 2 plus 1. It is. Yeah. Yep, you're always going to start with the one they give you, but it gets a new subnet mask.
Can I ask a question real quick?
Yeah.
I think I already know the answer here.
1 sec. So did you figure that out? So if you add take 128, because you're still looking at the whole octet. So take 128 and add 4 to it. So what's that? So 128 plus 4 is 132, plus 2, plus 1, 135. No, it's supposed to be 135. So this is the next network address. So see, if you have 29, you're going to increment by 8 in the 4th octet. So the next network would be 192.168.0.136. That would be the next network. So that can't be the broadcast address.
So on this one, the last number broadcast is the same.
No. You have that one wrong too. So change that one to the right to what it's supposed to be, 135. There you go. Yeah. So a broadcast will always be an odd number, and a last usable address will always be an even number. Exactly. Exactly. Yeah. Okay. Yes. Okay.
So that was our first one, so I changed it to 24.
Yes.
And then make this one down here, since it's in the 3rd octet, I change to 16 to 17, is that right?
Yeah. Because you're going to take this address in the 3rd octet and increment it by 1 to get this address.
So then I'm going to do the same thing on this one. Didn't do that right.
Slash 25 only has.
Oh no, I did it wrong. I didn't do this one right. This one we did. Sorry, it should be 17, 18.
18, right.
Okay, then I need to fix them.
Okay. Yep. So again, just follow the formula. It seems a little weird at first because you might be moving into a new octet, but it works. Yes. One 135, 134, 129. Okay, so let's look at this. So we've got a 96. So you've got that right, and here's our line, right? Okay, so let's look at this last usable address. So it's 192.168.0, and then just look at this number again. Figure out that number, because this is actually, it's not going to be 110. So look at the whole octet. So you still have to look at this as an octet. So 0, that's off, but 64 is on. 32 is on. 16, 8, 4, 2. So what would that be when you add those all up? Exactly. 96 plus. Oh, no. Is it 9? No, it's more. It's 96. 96 plus 30 plus 30. Yeah, plus 30. So 96 plus 30. What's that? I don't think so. 126. Yep, 126. And so you've got the same mistake on the broadcast. So if the last usable is 126, what number comes after 126? 127. Yeah. Right, and then see, we can kind of prove it because it was 127, and then the next network address is 128. Okay? Okay, so work on the next one.
So 18. We're adding 64 to the next one. Right? Yep.
Makes the math so much easier.
Perfect.
Well, Chase just confirmed it, so now we're Well, it took me 5 tries.
So
Yes.
if this is a 0 and this turns into a 17, so that means the previous one will be 16,255 for the broadcast, right? By that logic.
Okay, ask me that again.
So by the logic of that,
Uh-huh.
if this is a 0,
Uh-huh.
that means the previous broadcast will be -1, 255.
In the third octet, exactly, because you're turning on all the host bits. Yeah, that's why you still have to pay attention to what octet you're in. So if you're in the third octet, you subtract 1 from that and then turn on all the host bits.
Right.
Yes, because we're dealing with the hosts. We're dealing with the hosts. Good thing, good catch. And then to prove it, bit it out, right? To prove it, put the bits in there. What? Yeah, bidding it out, there's a lot of piece to bidding it out. Yeah, when in doubt, bid it out and just look at each octet's value. Okay? That happens. Look at each octet's value. When in doubt, bid it out. like this new table that I made. Yeah, I'm working on making it a little better too. Oh my God. When you're done with the second one, just let us take a look at it and keep working on it. I want you to get them, get as many done tonight as you can. Yes, yeah. Brody just asked if it's okay if you just bid out like the host portion or the octets where the change is, and that is, as long as I can tell that you know what you're doing so that if you need help, I can help too. Okay, so we got that. And then we incremented, and then you did it in the 4th octet. And then you figured out your next, and so you did a 191, 190, 129. We did a 1, and then we did a 127 in the 4th octet. Good job. Yeah, that looks good. Do the next one.
All right.
You look so unconfident. Okay, let's see, 24, 25, this is 18, that's a 25, so we did the 4th, and then we did 1, yes, and then we did this one, and we got a 120, yes, and we did that, and this is a 255, and da-da, and I think you got it. Okay. All right, can I get everyone's attention for a few minutes before you leave? Okay, so, I'm going to let you take this home, but you must bring it back complete on Tuesday to get credit for this. It needs to be completed. So if you need to stay here tonight to get it done and off your plate, you might want to consider that if you think you will forget to do it, okay? This needs to be returned finished on Tuesday to get credit for it. And Tuesday at the start of class, not when class starts, at the start of class, okay? And then I want to point out something else. So next week, you're starting to dig into the modules, like dig a little bit more into the modules, okay? And you're going to be doing Module 3. And Module 3 is, they're all important modules, but Module 3 starts to break down the OSI model, okay? And the OSI model is the basis of this whole class because each module after Module 3 breaks down a different layer, okay? So you're going to be doing the OSI model. I strongly recommend you watch my video. It's a little bit long, but it's really good. It's really good at explaining the OSI model, okay? And even if that's like the most important thing, even above the reading, I think, okay? You might want to watch the video first and then supplement it by chunking through some of that reading to build out your mind map. But if you watch the video, I think it'll help you a lot. So do a good job on your mind map and your cards. You know, again, think about the ways that some people shared how they did it. Try something different if you want to do it a little bit different, you know, reading and flashcards at the same time or reading and mind map at the same time. Okay? Any questions? No. That was practice. Okay. Okay, are we good? Have a good weekend. Make sure you keep practicing VLSM. If you find that on Saturday you forgot how to do it, that happens. Just read the directions on there and it'll tell you exactly what to do, and reach out if you need help. I'll help you, okay, if I'm available. We have tutoring on Friday. We have tutoring on Saturday, okay?
Oh, I'm on the wrong one. Well, that's fine. Oh, okay. There we go. There we go.
Okay, I did
Yeah, I really screw you up.
See that? You said you were gonna come by for those naughty people who didn't do
Okay. Let me see. Yes. Yes. Which one are we looking at? The second one? Okay. So let's see, it's 17, 255, 254. Make sure you include your slash notation. I see it on that one, but I don't see it on that one. Let's see, 129, yeah. You don't have to. I can tell that you know what you're doing. And if you do, just again, add them over here. These I know that those are networks. Okay, looks good. Good job.
Just finish this.
Yep. Mm-hmm.
Next month.
Good. Good job.
Right, though, I was able to get like first try to answer all these questions,
Yeah.
but I like looked at which ones were very, multiple parts. So then I just made it to several flashcards.
Yeah, like you can make 5 flashcards from like 5 PDUs, right? Yeah.
All right, we'll see you next week.
See you next week. What did you figure out?
The rhythm I need to do.
Good.
Cards were easier after I did every assignment for the month.
Oh, agreed. Yeah, I could see that that would be true.
So if I do all of the week's activities before Tuesday, then I can do my flashcards.
Well, you're working ahead. I like your spirit.
Well, that's what I got to do.
I am the same. Like, I'm actually a really good student. You know, like, I'm a good student. So it's hard for me. I always work ahead. So it's hard for me to relate when students like look at the due date and do it that day. I'm like, that would make me so crazy.
My life has just been a reinforcement of procrastination is your style.
I get that too. Yes, I know. That happens.
I came from Ohio in Montessori school when I was 8, moved out here. Montessori, I was learning long decimal division and multiplication in 2nd grade. So I come out here in 3rd grade and it's like, okay, snooze fest until 5th.
Yeah.
So it's like, yeah.
I know.
I'm right now procrastinating.
Oh.
There is value when you apply it properly. There is value to procrastination, like
A little
getting
pressure.
started early on a project, then putting it down, walking away for a few days, coming back a couple days before it's due, and finishing it up with cushion time. Hey, cool. Not my style. It's like, oh, let me start it. Oh shit, 5 minutes till class. I better get that. I better finish that out. Where did I put it?
Not like me turning things in at 11:59, literally.
I don't care if you turn things in at 11:59.
You're not going to get till the next morning.
Right. You know.
I don't think he was greeting. He was just like, you're really cutting it close.
And who is that?
The cybersecurity?
Oh, Martin Bensick?
Yeah.
Oh.
Yeah.
He's not for it now.
What does he do?
I haven't had this issue, but I had a friend who's also this program. He's like,
I was
yeah, he like turns stuff in at like 11:50 at night, the night it's due, and he's like, hey, you might want to turn stuff in sooner.
Does he say that?
Yeah.
Oh.
Multiple times I got messaged.
But why doesn't he change the due date then?
Well, for all of his classes, everything's due at midnight on Sunday.
Oh, everything is due. Oh, that's brutal. Okay, I will tell you, I used to do that. And it was miserable for students because they all wait until Sunday and then they're like doing like 30 assignments. So I spread it out so you do a little. Yeah, you can't put it off. Yeah.
The reason I didn't do so well.
Yeah, it's not necessarily because you couldn't have learned the material. Yeah, that's why I spread stuff out throughout the week. You know.
That was one of those classes. It was like a 69 in the end. And I'm like, well, probably deserve that.
Yeah, one professor I had, his final was on like a Wednesday night. So, like the Sunday before the final, he kept on messaging us like, make sure you guys do the final. Monday, make sure you guys do the final. Tuesday, make sure you guys do the final. Wednesday, you are late for the final. I'm like, what? I thought I had to do it the rest of the night.
Yeah, I think for like the one of my classes, he was very much like that as well. And I was this day before that it was due. I'm like, you know, I'll be fine in 2 days. No.
Oh my gosh. Well, I'm glad you're telling me. I'll keep an eye on you,
I'm
Marcus.
getting better about it. I'm trying.
It makes life a little less hectic.
Like,
But it also makes it a little less fun, you know.
Like, I actually, when I'm procrastinating, a lot of times it's because I just have so much that I'm doing that I'm like doing things like just in the moment that it has to be done, you know. It's not because I put it off, it's because I'm like, let me get this done, and I get this done, that, you know.
oh, no. For me, it was very much of, oh, I know I have things to do, but I don't want to do them.
Oh,
So then I do it.
yeah. I don't do that for school stuff. I might do that for some stuff.